Are you an SRE? A developer? A quality engineer who wants to tackle the challenge of improving reliability in your DevOps? You can enable your DevOps for reliability with Chaos Native. Create your free account at Chaos Native Litmus Cloud.
Hi everyone, I'm super excited to be here today. I'm Yshay. I'm a developer and CTO and co-founder of Livecycle. Today I'm going to talk about how to create an amazing developer experience when onboarding a new code base. I'm going to start by sharing a story or an experience I had a few years ago. So back then I led a team that developed an open source solution for feature management and for feature flagging and configuration management. Because it was an open source project that was developed inside the company, we wanted everyone in the company, every developer, to contribute code to this project. Because this project, to achieve that, we've organized an hackathon, and because the project was called Tweak, we've naturally called it a Tweakathon. And we were excited, me and the team. We've created a dedicated backlog for this event. We've added lots of documentation to the project. We promote the event, we printed t-shirts, and at the end, well, it didn't work that well. We didn't have many contributions, and the main reason we saw that most developers were struggling to run the project, let alone develop new features or test them. The problem was that the project was complex and they needed lots of help to run it properly and add code to it, and even when they start working on it after a few hours, the development experience was not working that well in terms of like debugging or code IntelliSense. And today I'm going to talk about the challenges we have when we onboard a new code base and how we can make it much easier. Few words about myself. I am a developer, full stack for the last decade and a bit more. I'm passionate about cloud development, backend architecture, user experience, developer experience. I really love functional programming. I'm the creator and maintainer of Tweak, an open source cloud native feature management solution, the one I talked about before. And I also care deeply about simplicity, consistency, and elegance in code. A few words about Livecycle. So we are building the next generation of collaboration tools for development teams. It's based on the idea of continuous playground environments, and our mission is to bridge the gap between coders and non-coders. Our project is currently private, but the beta is coming soon, and you are welcome to check it out. So let's start by describing how does it feel to start working on a new complex code base. So the first thing I'm going to do, I'm going to try and build and run the application. But I don't have necessarily the right operation system, so I need to see maybe the instructions are related to different OS. I might have missing or conflicting SDKs or programming language runtime. It can be the wrong version of Python or Ruby or Node. And in many cases, I'm starting with like installing the dependencies and the package manager for random errors, and they can be like difficult to debug. And they are not necessarily random, but they sure like feel that way. And after that, I'm going to, maybe the build is working, I managed to install like the dependencies, but the next step I'm going to run read the README and try to make it work because it didn't run properly. Apparently I need to run some magic script. Some of them I'm going to watch fail. Maybe I need to change the host file. Apparently this project requires a database, so I need to install the database. And if I'm out of luck, I might need to install something very intrusive like a root CI or something. But I managed to build and run it and everything worked, but, well, I'm here for developing, and suddenly the developer experience might not work properly. So debugging doesn't work, the IDE doesn't stop on my breakpoints, autocomplete or dependency management not work properly in the IDE. The flows of code watch and build doesn't work, and apparently I need to install Watchman or other tool. Hot model reloading doesn't work because of WebSocket issues or something else, I don't know. And there's also these external dependencies that apparently I need to manage them differently for them to work, and maybe I have like course issue or something else. So it's kind of a difficult experience. And after I manage to run everything and develop, I get to the integration test, and here it's bunch of tools and they are flaky and they are not working properly, and yeah, my head explodes. But the worst part of it all is that if I'm going to leave this project for a few months, most probably the next time I'm going to work on this project, I'm going to do all this stuff all over and over again because my machine changed and because the project changed. So yeah, that's difficult. So why is it so difficult? One of the reasons is because we have so many tools and so many SDKs and runtimes, and this like huge fragmentation. Also, usually when stuff working on a machine, we are not touching it. It's like it's work. I'm not going to install a new machine ever unless my machine like get viruses or get burned down or my hard disk is failing or something like that. We have like vast amount of different tool chains, IDEs, complex development workflow that can be really difficult to set up and break easily. Our own machines are usually polluted and overloaded with tools, which is really terrible. And beside the environment itself, the code bases also always introduce new tools and changes, especially in active repositories. And at the end, we waste tons of time and lots of frustration to get this stuff working. So what's the dream? What's the experiments we want to have? So the way I see it, we want developer environment that are consistent, that provide the same predictable experience. So I'm not going to get like these random errors because the environment is consistent. I want them to be reproducible. It's possible to destroy and rebuild them, so I can move to a different machine, or if I did some damage, I can just destroy and rebuild them like we do today with servers. I want them to be isolated. If I'm running several development environments, I don't want them to conflict with each other, so that I can have like this project requires this version of a node, and this one other, and this one requires this specific CLI, and they are not conflicted with each other. They should be like self-contained, meaning that all the tools I need to work in an optimal way on this repository and codebase should be defined inside. So it should be like easy to, I'm just starting to work and I have all the tools and dependencies and packages. And at the end, we want that this environment won't break easily. So we won't struggle countless hours to get things working again. And the thing is, we used to have some of these challenges around applications, and then we started to run them in containers, which have very similar attributes to the one I mentioned here, especially when we talk about Docker container. We have like this tool chain of Docker that allows to build and run this environment, which are self-contained, isolated to some degree, and reproducible, which is really nice. Now, few years ago, 2 years ago actually, VSCode, which is one of the most popular IDEs around today, introduced a feature to develop inside of a container. Now, the idea is simple. The application, the IDE itself has like two components. The front end run on our computer, providing a good and native experience. But the backend of the IDE, which is responsible for file editing, terminal, language server, extension, etc., is running inside the container alongside with our code base. And that way we have our repository and development environment running like in an isolated container, while we still have a great developer experience on our host machine. So how does it look like? I'm going to show several projects and examples that are available on GitHub. All the tools that I'm going to use in this presentation are open source and free to use projects, so you can like do it yourself. You don't need any other tool for that or something that require cost. And most examples there are far from bulletproof and use tools that are experimental, but they showcase how value we can get from running inside a container, the development environment. So let's start with a quick example. The first one I'm going to show is a project that do like a translation between image to ASCII art. The project is written in Go before we had Go models, so it has several challenges. Let's start to develop it. So the first thing I'm going to show here is that we have like, we are running inside the developer container. You can see it here in the status bar, VSCode, and you'll notice something very unique. If I'm going to run the command prompt and look if I have like the tools for Go, you see that I don't have them because they are not installed on a machine, which is actually a Windows machine. But here is a container that runs in Linux and have Go installed. So that's pretty awesome. Now, how does it achieved? Basically, VS Code, if it have like the dev container folder, it looks for an instruction on how to build the environment for this project. So we can see that we have a definition here of what Docker file to use, some settings related to Go, extensions that should be installed in the repository, like the Golang extension. We can see here that I already have Golang installed because it's part of the development environment. And post-create command that if we want to do like some initial script. Now, if we look at the Docker file here, we can see that we start with a basic Ubuntu. We are going to install Go, put it to our path, define environment variable that tell Go not to use Go modules, because the project, as I mentioned before, it's like an old Go project. We installed several additional Go tools. The dependency manager of Go, back at the time, that was called dep, that this project is using. And some configuration for our shell. So I have like the autocompleter for Go, because I configured my shell to have like extensions for Git and Golang. And basically everyone that is going to open this project in VS Code will get the same experience. So this project runs ASCII art, so I'm going to run it against an image. And I'm going to tell you ahead that it's not going to work because this project doesn't support URLs. And I want to add this feature, and basically it's going to need, I need to change the open image file here. I'm not going to do it right now because I have already branch for that, so I'm going to move to that branch. But you can notice that I have like a good experience here in terms of editing. I mean, everything here is auto-completed, fast, very, very nice. Now I'm going to run it again with my branch, and let's see. Oh, pretty nice. We have like the Docker logo, and I can even print my user profile picture. And yeah, that's works properly. I can run the test, and everything works. And I can also run our dependency manager to see everything work. Notice another thing that I'm working inside a directory that is a special directory because Golang in the past required you to develop in a specific folder for stuff to work properly. And I have here the definition of the workspace, and I define that I work inside this folder. So that's basically it. And usually, for example, if I was working it locally, I would need to install Go in that version, and install the dep manager, create like this folder of Go SRC with Go root, and stuff that is not that fun and might collide with other projects I have, also the environment variable and other tools. So that's pretty much the idea of a dev container. It integrated with the SEM, so you saw that I can move between branches. I have remote coded editing capability, not just editing the code, but also seeing like the autocomplete and everything work. We have like remote terminal, so it's different than the one I have on my host machine. It's internal terminal for that container. And we can configure our environment the way we want. So we can set the runtime and SDK and CLI we want, set environment variable as I did with the Go environment variable, Go modules environment variable. I can configure our shell, add some plugin, define the extension, the IDEs, like the Golang extension. So that's pretty cool. But can it work for more complex project? So yeah, and I'm going to show it. So the next project is a server app. Still a simple one. It's a Flask app that sends email based on SendGrid example. Here we have several new challenges for good onboarding experience. First of all is running and interacting with the server because the server is running inside a container. The second one is managing the secrets because we need an API key for SendGrid. And then there's debugging. So let's start with this project. I'm going to start by showing the dev container. So we have a dev container that is based on Python, and we have the extension of Python, and we have the Docker file that is based on image that Microsoft provides for a Python application. But additionally, I'm going to install SOAPs. SOAPs is a project by Mozilla that's designed to deal with secrets encryption and adding encrypted secret inside the repository. And that way I can use add the secrets of, for example, my API key and keep it in the repository, but keep it safe because we know that secrets should not lie in the repository unless they are encrypted. So here I'm using, we can see that we have like the SendGrid API key. It's like a JSON file, but it's encrypted. So we have SendGrid API key, email from sender, and we see the data is encrypted. I define what keys I want the encryption and decryption to use, and we can see that I have here a key install. It's taking for my machine. And the idea here is that I can use SOAPs to encrypt or decrypt value. I'll show an example with fake another additional file, and we see that I have like the some secret number, and I'm going to decrypt it. So how does it work? I use SOAPs -d, and we can see that we have the value 42, very secret number, the meaning of the universe. And the idea is that using SOAPs we can put secrets inside the repository, but they are safe because they are encrypted, or safe to some degree. I mean, there are some trade-offs here. So my init file here that I have is basically taking the dependencies and it's going to insert them inside an end file. So I'm going to have like an end file for the application. I'm not going to show it here obviously. And basically, I have an app of Python that is running, that can run. Additionally, I want to show you that I have the launch JSON for VSCode here that define how I'm going to run the application itself. So if I'm going here and I click, I'm going to run the application with a debugger, and everything should just work. So let's see it. I have here like a Melinator box, so let's try to send email to it. Okay, we got an email, and that's work. And I'm going to show additional cool thing that I can use the app here, and I'm going to put here a breakpoint. And let's send an additional email. And we see that we stop here at the breakpoint. We see the data here of the object message, and everything looks just awesome. Now you've noticed here that I'm running on the localhost, but the application is running inside a container, so how does it work? So basically, we do a port forwarding here. So we define that port 5000 is going to run on my machine. Basically, the IDE is going to do it automatically, but I can also define it inside the dev container here with for ports 5000. Okay, so that's it for this example. We saw how we use SOAPs for encrypting secrets. Actually, this practice is common when dealing with GitOps, when doing like deployment to production, and we want the production file configuration files to be source controlled. There are other solutions, Git Secret, Gitcrypt, some others. The good thing about SOAPs, however, that it's really flexible. So I shown an example with GPG keys, which is nice to start, but it can be difficult to store these keys safely. But the good thing about SOAPs is that it can integrate with cloud encryption and service solutions such as AWS KMS or Key Vault, and basically the services change the problem from storing private keys to having the right access controls for keys. So it's really nice, and that way we can have like secure access control with SSO and everything that we need. And the key never leave the cloud provider, the private keys. The metadata is also saved unencrypted, so you saw that the JSON contained the name of the keys we want to encrypt. So it's nice because we can do like diffing and check history easily. So that's pretty cool. I also showed the example of using the IDE settings, define a launch JSON file for defining the debug configuration and doing port forwarding. So let's move to the next project. I'm just going to close that. Okay, so the next project is actually a real big project. It's called Abetica. It's like a big application that is, I think, like have been around for like, I don't know, like 8 or 9 years or something like that. I remember using it in the past. It's like you have like a task management solution like Trello, but more sophisticated, like with habits, and it's designed for your own life, for organizing your own life, and it's completely gamified, so like an RPG, and it's really a cool project. Now, and it's an open source, and also like a website. And we have new challenges. It's like a huge project. We have front-end, back-end, and a database here. And I'm going to show how we are going to run it. Okay. So here is the project. And let's start again by checking out our dev container. Because the project is kind of heavy, I already run it, so to save us some time. So here is the project. Now you see that I'm not just using a Docker file, I'm using a Docker Compose file that define the environment and not just the IDE, because we want to have like a database here. So here we have like the Docker Compose. This is the dev container itself. We can see that we inject some environment variable and define the workspace. You can ignore these labels for now. I'll explain them later. We have the DB here, which is a MongoDB. We have Mongo Express, which is a tool I've added that can provide us visibility to the Mongo, what's going on inside. We have traffic, which is a reverse proxy that I'm going to use because this service have like lots of port, and I'm going to run everything like on a single port. And we have the Docker file that include the Mongo CLI tools and JavaScript node version, basically. So you can see that if I open here a terminal, I have here like the Mongo shell. Sorry. So that's it, and I also have extension of like Mongo and VSCode DB extension. Okay, so let's see. The first thing I'm going to show here, I'm going to run all the project here. So we have the client and the storybook agent running, and I'm going to run the server as well. Now, this project has like many applications that are running. So we have like the UI application that is basically a storybook to see like the design system of every component. We have the docs, which has like the REST API and everything. You can see that everything is running currently locally. We have the application itself. And I've also added like the Mongo Express, which contain like the connected to the database. And I'm going to log into the application, so I'm going to need a user, and luckily the application already have a user here, the test user, which I'm going to use in login. Okay, that's weird. Let's see. Oh, the server is not running for some reason. Let's see what's going on here. Maybe I've exhausted the resource here. Oh, okay. So yeah, now it looks like it's working, or at least it's loading. In the meantime, how did I have this user? Basically, I added here some data, which are initial data that I'm using for data setting. And when the dev container is created, I'm also going to do like a Mongo import and add the data to the database. So everyone that is going to run this project is going to have the initial data. And we see that the login works, and here I have like my test user, and with mission like cardio or process email and stuff like that. So this is like a complex project. We see that we have several application running, servers running. And to achieve that everything run on the same port, we see that everything is on port 8000. I've added the reverse proxy, which is defined in the Docker Compose here. It's called traffic. And the idea is it's listening on port 8000, but based on the labels the other services have in the Docker Compose, it's going to redirect traffic, for example, for Mongo localtask.me to the server Mongo Express on port 9000. So and the same goes for the application with the docs, the UI, and the local test. So that's basically this application. I'll stop it because it seems more heavy. And let's go back to the slides. So we saw here a full stack application that uses Docker Compose and a DB image of Mongo and additional tools like the Mongo Express. I did some data seeding with basic scripts. Alternatively, we can clone data from staging or production if needed. I showed the example of using a reverse proxy. So instead of using ports which are shared, we don't want to exhaust them. I'm using like a wildcard, and also it's more convenient to use subdomains than numbers. I'm using like a wildcard localhost DNS. So basically the localhost, localtest.me, or there are other domains like XIP, are domains that every subdomain of these domains is going to point to our localhost. So very cool trick, and you can also create one yourself if you, in terms of security, and not using the public one. And we use here Traffic, which is a very simple and developer-friendly reverse proxying. The nice thing is read the Docker Compose definition, so it's very easy to use, and it also integrates well not just with Docker Compose, also with Kubernetes and other tools. So let's go to the next example, and the next one is personal. That's Tweak, the project I talked about before. It's a cloud-native open-source feature flag and configuration management. It got lots of microservices, several DB and messaging system, cross-communication, polyglot environment. We use TypeScript, .NET, and Go. Complex architecture, the services talk with each other, and you don't need to understand this picture to see that it's a complex thing. And we are going to run it as well inside a dev container and provide great experience. So that's the project of Tweak. The first thing I'm going to show is that in the Docker file, I'm going to install Docker in Docker. So the idea is that instead of using the Docker host we have on my machine, I'm going to use an internal Docker, a nested one. So you can see that my Docker PS here is empty, and if I'll run the same command on my computer, so naturally I'll see all the dev containers. So here we see like it's a dedicated container for this project, a dedicated Docker daemon for this project. I'm installing .NET 5, Golang, Node.js, and Yarn. I have all the tools I need for development, and I'm also installing Tilt. Now, Tilt is a very nice solution that is designed to solve the problem that in Tweak we have like the environment itself is developed inside a container. That's the easiest way to develop Tweak. So we have like this YAML that defined all our services. And what Tilt does, it basically provides us a tool for editing the files and changing them, and replacing code inside the container or rebuilding our images in an automatic way. So how does it look like? I'm going to open additional terminal here, and we see that all the services of Tweak are running inside the nested container. And in Tilt, it also has UI to see the application here. So let's see that we have Tilt here. Let's see that it's running on the right port. Yeah, okay. So that's the Tilt application, the Tweak application. We can see that all the services that are running Tilt. Some of the services are services of Tweak itself. Others are tools for mimicking the cloud environment. So we have, for example, Minio, that is a tool for object storage like S3. We have NATS, which is a message broker for passing messages, Redis, which is a database that in the cloud you can use like the hosted version of it. And we have our ADC server mock, which is like an OpenID Connect provider. In production, we can use Google or something like that. And we have the other services of Tweak. And the idea is that every time I'm going to do a change to the code, it's going to either rebuild the project or try to do auto reloading. In this example, I'm going to show like an auto reloading example. So here is the login page of Tweak. I'll just refresh it to make sure we are working on the latest version. And we see we have the page here, and I'm going to change the title here, make it a bit bigger, and that's basically it. And yeah, we see that it worked instantly, and it's pretty amazing. I mean, I wish we had that kind of developer experience a few years ago when we did that hackathon. It will be totally a game changer. So that's really amazing. So let's go back again to the slides. So we saw the example of Tweak. In Tweak, we are using nested containers. So we have like Docker and Docker running inside. There are different ways to run it, but if you are using nested container with Docker Compose, Tilt is great for watching, rebuilding on every code commit, or doing code reloading or remote debugging. Everything works. It can be a bit slower because we are running again inside containers that also run inside a container. Tweak also uses the practice of mocking cloud dependencies to work properly. So we have Docker images of database, we have wire-compatible solution like Minio or IDC Mac server. Other tricks you can use to mock cloud dependencies can be manual mocks or full frameworks, like local stack. And the last example I'm going to show is KubeCost. This is actually an example that we run our dev container inside a complex platform. In this case, the platform is Kubernetes, and we need to install KubeCost is a tool for managing the Kubernetes cost. So we need a Kubernetes cluster, we need a metric server, and we need Prometheus, which is like a monitoring solution. What can we do with Kubernetes? So the first thing to remember is that Kubernetes local development is already difficult today. We have fragmentation, we have different versioning, we have different distribution, we have like Minikube, Docker for desktop, micro Kubernetes kind, K3S, and everything is a bit different. Now and you notice this differentiation, especially when you develop in a project that use like the Kubernetes API. So using a single Kubernetes distro and version can make life easy. And I'm going to start with our example. And that's the last one, as I mentioned before. So inside this dev container, you can see that I have a Kubernetes running. That's awesome. I'll just also here going to turn down Tweak because again it's like every project. So we have the dev container JSON here. We define like the extension we want to have, YAML, Golang, Kubernetes tools, and the Docker file here install not just Go and Node.js. We also install here Docker in Docker. So we have a nested Docker daemon, and inside we are using a tool called K3D, and also we install Elm. So K3D is a tool for provisioning K3S clusters. So we can see that I'm having a cluster here that is running. And the idea is that K3S is a very minimal distribution of Kubernetes, so it can run very fast, and it's also like a single process. So it's very awesome project. Now I'm going to run Tilt as usual. And if you'll notice on the contribution guide here, basically when you want to build, they tell you to Docker build a project, edit the deployment YAML file, set the environment variable to the Prometheus server, create namespace, apply, and basically, the good thing about it is that if we are using these tools, we don't need to do it because everything is happening automatically. So Tilt is also integrated with Kubernetes, and in this case, we actually have a registry. So every time we do a change, you can see here that we have a server and a kube cost registry here. So every time we are going to do a change to the Golang code, so Tilt is going to rebuild the project, push the image, and replace it in the Kubernetes deployment. So that's pretty amazing. Let's see that our project work here. So we have this project also has UI, and also this data here. We see that we have here the data. We can see it from today. We can see it by pod, for example. So the different Kubernetes pods that are running. We can see that the API is running. And basically the Tilt file definition here, we define how we build the image, what the Kubernetes YAML we are using, and also I define the resource for the UI. So for the UI, we'll still have like auto loading, and the UI itself is not running in this case in Kubernetes. It's like a local resource. And just to showcase how fast is K3S, I'm going to like delete the cluster. K3D. Okay, and let's run it again. And you'll notice that I have a running Kubernetes server in less than 20 seconds. So that's pretty amazing. I mean, we can see get nodes, get pods. So that's really amazing. If you've used Kubernetes other distribution like Minikube or Microservice or even Kind, you will see that, I mean, usually it takes some time. And the good thing about K3S and together with K3D, that is, it's very fast, and we have also a dedicated registry. The cluster is stable. Also, K3S has special integration for Helm, so we can install the Helm chart declaratively. That's what's actually happening with the Prometheus. We have a Prometheus file definition there in the repository, and we have Tilt that facilitate building, publishing, running. If we put it in terms of what's happening in this example, so we have our Docker machine, our Docker host. Inside we have a dev container. Inside we have our IDE. Inside in the dev container we also have Docker and Docker daemon that have like a registry, a K3S node that run containerd that run our application. Or if we'll try to put it like more visually, it's something like that. So no more demos, and thank you for your patience. I hope you enjoyed it. So I'll summarize. So we use containers development environment. The cool thing about it is that development environment configuration is also source control. The development machine stay clean, can scale well to multiple environments without conflict, as you see in this presentation, and it can run locally or remotely. Our setup in Livecycle actually is composed of lots of microservices and fronted with threat model reloading. We have our own Kubernetes custom resources and controllers, GraphQL engine, full-blown CI system, stuff related to SSL certificate and dynamic DNS, a lot of CLI tool for code generation, and at the end, the time to tear down and build all the cluster and the dependencies locally for development is less than 15 minutes. Time to build, run test code changes like 10 seconds. Time to onboard a new developer including revision, provisioning in host on AWS is less than 3 hours because we are working remotely. You can work either remotely or locally on your Docker. We don't have working on machine occurrences. It's very easy to introduce new tool. We don't have strain on our developer machines, and our team can work both with M1 and Max. In the future, we hope to optimize it more. We have to have shared build cache, snapshots, maybe use a cloud provider that will provide us the best dev machines. There are some drawbacks, however. The initial setup can take some time to work. We need to code everything. We use many tools. Some are bleeding edge. Basically, using dev container actually make you feel like, yeah, I'll add additional tools because it makes it easy because there's no installation, but we need to be careful with that. There's additional code to manage, obviously, the code of the Docker file and the definition. Dev environments are not standardized yet. So in our example, we are using the definition that are defined by VSCode. So naturally, we are pretty coupled to VSCode. There are some performance issues. And there can be security challenges between development and production context, especially if we use secret encryption. There are alternatives to VS Code, but I haven't tried them. So it can be possible to use like terminal-based code editors and working on a remote container. There's Gitpod.io and FIA that have similar features with Gitpod YAML. I played it a lot. I played it like in the past, but not on complex environment. JetBrains as a solution for a remote environment by using JetBrains Projector. I haven't tried it, but it's supposed that you work on a remote IDE and it's like projected to you or something like that. And we can run local IDE with Docker mounts, but I don't recommend it that much. I haven't shown an example of serverless, but it should be possible. I mean, if you can run it locally, you can probably run it in dev container, and the same rules apply in regard to mocking cloud frameworks. So use cloud mocking frameworks or WAR-compatible solution like Minio. And if necessary, you can maybe throw infrastructure as code tool to the mix to do a dynamic provisioning. Native mobile is a different story. On this, I'm not that optimistic. I mean, it might be possible to stream application, but mobile emulators are heavy, and the container ecosystem is optimized for Linux, and the IDEs are very tailored for mobile development. It might be easier with cross-platform frameworks like React Native or Flutter. I will say, however, that this problem is really difficult. I remember having like epic battle with my IDE that I work on with the IDE and the tools when I worked on Android or iOS development. So I hope it will be better in the future. And the nice thing about it is that we're seeing a trend that is about putting more stuff in the repository. We see that in the last decade we added more stuff. It's not just the code. We have our design system there, the Open API specification, documentation, infrastructure as code, secrets, notebook, and the workflows are based on the repository, PR workflows. So it's really nice. And I think that in the future it will be more. So the idea is that every repository will be self-contained. All the code, tools, knowledge, and definition are in the repository. Git acts as a single source of truth. Code is more accessible. The barrier of entry is lowered. The applications are portable, which is nice. And we can control the developer experience, which is it's very empowering that if I'm having a repository, I can also control how to create an amazing developer experience for developers when they start using my project. And I believe that these trends will create an emerging tool of ecosystem. We already see it with like remote IDEs and PR environment solution, and even tools like Livecycle that take the repository and create like a live version for other team members to collaborate with. So I'm very excited about it. And I've shown many tools and patterns in this demo. So this is like a pattern and cheat sheet table that you can use. But everything is going to be like on my repository, and I'm going to post everything on my Twitter account as well. So thank you very much. It's been a pleasure.